Hello everyone, welcome to our webinar about SAP data in Microsoft context. Here we will share 5 things that we have learned about building a data lakehouse working with SAP data. The short introduction of ourselves. My name is Pascal Boekenstein. I'm a senior analytics architect and I've been working for element61 for the last 3 years, in total 6 years of experience. The 3 years before element61 I spent as a PW consultant working at various clients, and then I transitioned into a Microsoft context. So with that expertise, I continue to help clients working with SAP data and in an Azure context. And in my free time, I like to mountain bike.
All right, everyone. Hello, my name is Tom Claessens. I'm an analytics architect with almost 2 years experience here at element61. I'm mainly involved in data engineering and data warehousing, where I help clients set up data lakehouses to get the most insights out of their data. Besides being a data engineer in my free time, I love to travel and I do some outdoor running.
So practicalities of the webinar. We will share the recording on request. We have an extra colleague on our side to handle the questions in the chat. And if you have some experience, some issues, then please leave and just re-enter. So what we will talk about today is a short introduction about element61. We will talk about what a data lakehouse is and why it is inevitable to acquire one. And then we will share some of our, we'll share 5 lessons about it, and then we'll have a Q&A session. But first, element61. So element61, we are about business intelligence. We're doing various kinds of topics related to business intelligence. We work on data science and analysis, and of course the newest kid on the block, we're working on artificial intelligence and machine learning as well. And besides that, we have a competence center specialized in performance management, going from PPC to Profix to all kind of performance management tools that are working on planning, budgeting, and forecasting. Typically, we work on our projects in a coaching and co-development phase. So what does this mean? That we'll teach our clients how to work with the platform, how to understand the different topics that we're working with, and really enable our customers so that they can host their platform themselves without needing an external party to do that. Our sweet spot, so this is the clients who we love working most with. We focus on Belgian customers, customers who have a headquarter in Belgium and who have international ambitions. And this is just a slide with some of the references that we have.
All right, perfect. So now that we know what element61 stands for and how we help our clients, let's move on to the main topic of this webinar, which is what are the 5 lessons we learned from building a data warehouse or a data lakehouse on your SAP data. Now, before diving into these valuable lessons, it's important to maybe first understand the foundational concept of what we're discussing, which is what is a data lakehouse and why it is indispensable. So let's take a trip down memory lane and look at the traditional data setup, which typically revolves around a data warehouse. For people that that are familiar or that have been working with data analytics in the meeting, this picture will probably look very familiar, where you have your different data sources on the left, which we will extract, then transform, and then eventually load to our data warehouse, where we typically store our data into this dimensional data model, after which we can actually use this data in all sorts of tools like Excel and Power BI to get insights from this data. Some key benefits, of course, we have this integration of multiple data sources stored into one single location, so we can really get an overview, an overall overview of the data. We have this improved data quality using these ETL processes. It ensures that the data is clean, it is transformed, and then also standardized before it enters the data warehouse. It's typically built for data analysis, and we model it in a dimensional data model, which we can then very easily use in tools like Excel and Power BI to get insights from this data. And finally, we will have this reusable data warehouse. So we will have this one version of the truth where we can then build various reports on top of. Now, what we see is that the world and the times are changing. And first of all, we see that real-time reporting becomes the ambition. We want to do BI in real time and combine this with historical data. Furthermore, the data is becoming bigger and unstructured. You can think of clickstream data, machine learning logs, but even video and audio that you might want to use in your analytics projects. And finally, data is asked to deliver more than just reporting. And we might want to engage in AI analysis or even in API product deliverables. Because this times, because the world is changing, we see that Data Lakehouse is becoming the paradigm used for data analytics today. Or you see on the left, we have the traditional data warehouse that we just discussed, but we want to do more with this. We want to do data science, we want to do machine learning, and we want to do this based on data that is maybe semi-structured or even unstructured. And so what we want to do is we want to combine the strengths of data warehouse with the strength of the data lake, which will then be the lake houses. So the data lake on the one hand, which will be very strong for machine learning, but will have very poor support for business intelligence. On the other hand, we have the data warehouse, which is great for business intelligence, but it has very limited support for machine learning. That's why we really want to harmonize the strengths of the data lake and the data warehouse to our lakehouse. The lakehouse today is the reference architecture by Microsoft because it's proven that it allows customers to do best practices data warehousing while still benefiting from scalability and simplification. Maybe important to note is that a lakehouse can be built both in Fabric and Databricks, and we see that they overlap in both offering computes to transform and serve data, but they have both their strengths and weaknesses. There's no one size fits all. For certain use cases, Databricks will be the preferred architecture, whereas for others, Fabric will be the preferred architecture. It's also important to note that in the slides that follow, Databricks is typically denoted as your architecture, but it's important for you to know that we can also build a lakehouse on Fabric. Now, where will SAP come into play? We see that SAP will come into play on the left side. It will be the source where we will extract data using certain tools, store it in the data lake on which we will then build our data lake. When we see SAP as a source, we will identify some. One of the first is no one size fits all for accessing the data, which will immediately be the first lesson that we learned.
Thanks, Tom. Yeah, so there are a lot of deployments of SAP, a lot of versions going around, and each of these deployments, they have their own preferred method of extracting the data from these sources, but they also have different options which you actually can compare in terms of some parameters that we have decided upon. So like the technical aspects, performance aspect, and the knowledge that you have of SAP. So I'll shortly discuss those 2 points, and then I'll give some insight on how to map those to the different options that are available. So the technical aspect is already mentioned. So the source, what are we looking at? Is it still an old ECC? Is it an S4? Even the BW is possible to extract the data from. And then if we have determined what source system it is, there's also a version, especially when it's coming to S4, we have a public cloud and a private cloud with a different method of extracting the data. And of course, the backend of these sources are also important, although most of the SAP clients are already running on a HANA database. It still occurs that there is some SQL or DB2 present, and that will also have an impact on how we will work with extracting the data. So when we have decided on the technical aspect, we can look at the method of extraction. And for this, we want to have an open mind actually, because it's very important for us that the client is comfortable with the way that we are extracting the data. So that means that there are options. We'll map them to these certain parameters that we have set, are saying here, but it all depends on throughput. How fast can we extract the data? That we have to compare to the durability of the data. So when we are looking at an ECC system, do we still work with extractors, or are we already going to look at the tables of the database itself? So like, how easy can we migrate from one system to another system? And then lastly, it is important that your developers are confident in the objects that we are extracting. So you can look at an extractor as maybe as a bit of a black box, but clear to understand where the data is coming from. So your developer, or we need to have more insights about the pre-built objects, and then compares to the knowledge of our data model of the SAP system. So if we look at all the possibilities on the left, public cloud, S4, BW, ECC, and then we'll map this to the different parameters that we have. So if we look at an ECC, you see that we have calculation views. If you're running on a HANA database, this gives, of course, a very high throughput. Durability, it a little bit depends on on the table structures, of course. Which module are you looking at in the predefined logic? There can be logic already existing in your HANA views, but it can also be just a plain table visualization, virtualization, and you can make this available through the HANA connector in ADF, but you can also use a different tool. About the tooling, I will come back a little bit later in the slides once we have seen all the different options. So if you go to the application layer of ECC, typically you can go to the tables or the extractor itself. So then we look at the table connector or the CDC connector from Microsoft, each with those different aspects mapped to performance. If we look at S4, then we see that we have some more options available. We still have the calculation views, of course, with the very nice throughput. We also have CDS views. The HANA CDS views is not really something that we actually use a lot, but for the completion, we have added it to this slide. And then we're actually comparing the ABAP CDS views, and then usually also comparing this to the tables. If we look at the BW system, we can look at it from an ADF point of view. You can use OpenHub or MDX, and then you're really going to the info objects itself. This is one of the least preferred options, I would say, as that structure of the data is really hard to map, and the performance is also not that great. BW, it can also be accessed through the HANA database itself. The HANA database, again, it will give a nice throughput because we go to the ODBC driver. But here we need to be careful that we are that you have the correct license applicable to your system, to your SAP solution, so that you can actually use this method of extracting the data. So we have a lot of different challenges, and these challenges come with some solutions, as in how are we going to extract the data. And for each problem, we have a tool selected, and those tools will come later on. So those are the options that we had of extracting SAP data. But now, what do we see when we are actually extracting that SAP data? So we are experiencing a couple of challenges. So one of the challenges volume. A lot of business processes are in there, so it will generate a lot of data. The data model itself, real-time data, and then an SAP note of February, which is stirring around some of the data extraction from raw options that we have available. So if we look at the volume, here we see that we have, there's just a lot of data available, especially when you are in S4. If you have account-based data as a Docker, and the table can go very, very, it's a very wide table. It can be a very tall table. So there's a lot of data in there. So we need to have an idea of how we are going to work with this data most efficiently, as in storing it. Just copying the whole table to your data lake is probably not the most efficient way to do it. Processing the data, a full load each time is probably also not the most efficient. So we need to think a little bit about how we want to work with this. And further on, if we work with sorry, if we work with the data, we want to make it as available as possible to everyone, especially when we are in the self-service context. It is important for us that we can make this data available in a meaningful way that is also accessible by everyone and understandable by multiple people. So the accessibility and extracting of the meaningful insights, it's a bit tied together. Nonetheless, important to think about this when we are ingesting or extracting data from SAP. So when we look at the data model of SAP and the data structure, it is probably no surprise to you that it is a complicated system. On the picture, we see a PS data model, just a subtract of it. We have over 130,000 tables available, all with a very meaningful name, also a very meaningful column header. So that can be interesting to dive into this model and to find your way around it. So that can be it can be costly. Why is this also a challenge? Is that not all the tables are working as we want them to work. We don't always have a clear change data marker available, so we don't really know when a row has been updated or even when it has been added. So yeah, it can be difficult when you need to look at the header table and all these kind of things. And of course, there is no extensive documentation available. The other challenge is that we see more and more real-time data requests. And then I'm not talking about a daily refresh of the data. We really want the data almost as soon as it has been inputted in your transaction code. You want it to have it available, in your system. This is a challenge because the compute that we had previously, that was just not the performant. Also, we don't want to have a big footprint on the source system. So yeah, that's why we had typically our nightly loads to reduce stress on the system. So those are the three challenges that we had before the 8th of February. But then on the 8th of February, SAP gave us a nice little surprise. I will not read the whole slide, but if you have access to the SAP thing, you can find this number, and then they're saying that we are not allowed to use the ODP framework anymore through an RFC connection. They say it is still allowed with an OData connection, but that means that we have to make every CDS view, every extractor, we need to make them available through a web service so that we can actually address them. Microsoft is currently working on a connector which can access this OData version of the ODP framework. I think it's it's almost being released in a public preview, so they are also working with this node. If you are using any other tools like the ADF CDC connector, or you're using a Theobald, which is using then the ODP framework to extract the delta of those objects, we need to see how we can work with that. A side note that I might want to give is that an SAP node, it can be a little bit weird to interpret this because it doesn't really have a legal basis to prohibit the usage of the ODP framework. So it could be that it is a little bit in conflict with the terms and conditions that you have agreed upon with SAP itself. That being said, You can also challenge SAP directly on this and let your procurement or legal department contact SAP and let them ask questions about this node. So the extraction tools. So when we just discussed all the possibilities that we have, all the different systems with then the possibilities that they have to extract the data. And then we're now going to look at the tools that we have. This is not a complete summarization of all the tools that are available. These are the tools that we prefer to work with the most, and are also seeing the most of our customers are using these tools even before we advise them on an extraction method. So we have Azure Data Factory, well known probably. This tool, yeah, it can use the RFC connection, but yeah, of course, be aware if you're using the extractors with the ODP framework attached. This is just almost plug and play. You just fill in your parameters of your system ID, and you can connect to any of those objects that you see on the right. So the SAP CDC connector, that's the one using ODP. The SAP HANA connector is then the ODBC driver connecting directly to your database. Then the SAP table, that is the table connector, which is using the RFC module, RFC read table 2, I think it is, so which is using the application layer to extract the data from it. What's important to know about Azure Data Factory is that you need you need a VM. The VM, this is required to have the network established between your SAP system and the ADF connector, and it's pay-per-use. A different tool, a more revolutionary tool, I would say, is Fivetran. Fivetran has been around for a couple of years already, and it's a quite interesting technology. They use their own proprietary IP to read what data has been changed on the database. So they're using log files of the source system, and with these log files, they are able to replicate the changes that are happening on the source system. So what they do, they will do initial full load. This is either, it depends a little bit on the licensing that you have, if it's an enterprise or runtime license, but they offer a full load for free for the first time, and then they have their own pointer, and then they are able to track the changes that are happening there. I've seen some demos about it. I will not demo Fivetran right now. I leave that to them. But the performance is quite impressive. Also the footprint in the system, that's really really remarkable. There, it's within a couple of seconds that the changes are being tracked actually by the student and being offloaded into the data lake in basically any format that you want. So if you already have your Data Lakehouse running with Delta tables enabled, and Fivetran can offload it into a Delta format as well. The picture that I'm showing is just one of the deployments that they have. They have a couple of deployments. Two of these deployments require a virtual machine to be installed, and there could be transport necessary as well to make sure that it can read the data from the source system. And the newest version that we have made available is a complete SaaS version, and this will only be able to connect to S4. Another tool that we see quite a lot is Theobald. Actually, Theobald is a tool that you need to install on a server as well. So you also would need a VM or just a server where you can install this tool, and it's quite simple, plug and play. It offers a lot of connectors actually to the SAP system. They still are a certified tool because they can work with the NetWeaver stack quite efficiently. And you see here all the different options that you have. So if you have an SQVI, you can connect to it. You can use Delta Q, ODP, hierarchies, PW. It's very well integrated with, but be careful. This also will use the ODP framework if you want to offload in the Delta. The cost of this one has to be agreed upon with your account manager of Theobald and your company. So those are the three tools that we see quite a lot, and I wouldn't be a consultant if I couldn't map it on a matrix. So I've defined two axes, and on these things I have placed one risk, the other one complexity. At risk, we see, of course, the stability. How well is this tool running? How much do we need to perform to keep this tool alive? And then, of course, the impact of the SAP node. Do we need to rethink the way that we extract our data if we are going to opt for this connector? And then we have the complexity of the tool. So yeah, the setup time, the error handling, and the skill level, how to work with So here we see 510. We plot 510 with a very low risk actually, because it's a very, you have a web interface which is quite easy to navigate through. You just need to select the tables that you want, and then it will be offloading the data into the data lake. It is not using ODP, although it will offer some support for CDS views in the public cloud solution, which can then be using the ODP framework. But since this is using the OData, there is no risk of using 510 for that. The complexity, we put it on a mediocre complexity, not high, not low, because you're still working with the tables that SAP are giving in there. The second option that we're looking at, so we zoom in a little bit more into ADF. In ADF, we have the multiple connectors, and for this specific table connector, we say that the risk is still low because we're not using the ODP framework, but the complexity is getting a little bit higher because we are working with some tables which have a lot of data. Think CD header, CD pulse. Yeah, we need to work with the delta, and we need to make sure that we're not just full loading this table every night again, because that will probably never work. So here we need to think about a strategy on how to offload these tables, so hence the complexity is a little bit high. A third one is the CDC connector. Here we say that the risk is quite high. The risk is we think it's a little bit higher because of the ODP node, which is in there, but it's using the ODP framework, hence the complexity is lower. You don't have to worry about extracting the data in an efficient manner. It will be able to use the data through a mapping data flow, which will then spin up a cluster in ADF, and it will make sure that your bronze table is always consistent in there. If you still decide to use this connector, again, do note there is this SAP node which says you cannot use the ODP framework, but you can choose to ignore it and let your legal department have a battle with this. What we see SAP recommending when working with this node is their own solution, SAP DataSphere. SAP DataSphere, you can use your CDS views, you can use your tables, you can use a lot of the SAP sources which are in there, of course. And then if you use a replication flow, you can offload the data into your data lake. The replication flow, if you select that you will not store the data in your DataSphere, you can actually have a very interesting license, but it does require an additional license in this setup. You will also create a more scattered landscape, of course, of tools to see how you can extract the data. So think about it when you decide on adding an additional tool. And here we see them all at once with a little subtext.
All right, perfect. So now we've seen where we can get the data, where the data resides, and what the challenges are with ingesting the data, and what tools we can use. And now it's time to actually go to our third lesson, which is that we should think about data loading strategies. Pascal already mentioned that in some cases, maybe full loading would not be ideal. So therefore, in this lesson, we will see what the different loading strategies are, and depending on your use case, which strategy might be beneficial for you. Typically, we define 3 loading strategies that we can distinguish. First, we have the full loading strategy. Next, we have loading with logical partitions, and then finally we have the incremental loading. And let's delve into each of them, discuss their pros and cons, and see how you can effectively utilize them depending on your use case. So as already mentioned before, we actually identify 3 strategies. First one will be full loading. Full loading is the simplest type of ETL process where you just copy all of the data from your source to the target, regardless of your data has changed or not. So even if your data didn't change, you will still do a full load from your data from the source to the target. This means that we will purge the data before loading and then ingest the source data, empty data. It's a simple and straightforward loading strategy to implement, yet it will be the least efficient. Next, we have loading with logical partitions, which typically involves segmenting or dividing our data into these smaller and more manageable chunks based on logical keys such as dates or product categories or any other relevant attributes. Each partition can then be processed separately during your ETL process, making it faster and efficient, and hence we will identify it as being more efficient than the full loading strategy. And then finally, we have the incremental loading strategy, which involves only loading new or modified data from the source to the. But implementing the incremental loading strategy requires us to have some kind of a mechanism to identify new or updated records in the source since the last extraction. This can either be some kind of a watermark column, such as your timestamp or your version number, or we can use change data capture. Now, if we delve a little bit into the pros and the cons of our full loading strategy, we see that the biggest pro, of course, of a full loading strategy is that it is very, very simple and straightforward to implement. If you have a simple table or you want to do a quick ingest, I think the full loading strategy is really something to consider. And finally, of course, you have guarantees that all of the data is current and complete. So you will not miss any data. And if any of your rows are being deleted in the source, this will always be reflected in the target. The negative point, of course, is that it is very resource intensive. As Pascal already discussed in one of the challenges, we see that the volume will become a very big problem with SAP data. So if our tables get larger, we will see that it will put a very high stress on your source system, on your network, and on your processing units. Furthermore, it is rather slow and it will be time consuming for sure if your tables become larger. Therefore, we will typically use this strategy to a one-time reload during the night. The loading with logical partition strategy will also offer some advantages. And the first one is that it improves efficiency because we will partition the data into these smaller chunks. We can actually process these smaller parts in parallel, which will actually give us a significant gain in efficiency by reducing the load and contention time. It's also highly scalable as it allows for the addition of more partitions to accommodate for growing data sets. However, there is also some drawbacks to this approach. Managing these partitions adds a layer of complexity and maintenance. You will actually need more overhead to decide on your data loading, on your partitioning strategy and so on. Another potential issue is data skew, where these uneven distributions of data across your partitions can lead to performance bottlenecks. If some partitions become significantly larger or more active than others. At last, we have the incremental loading strategy, where there's 2 potential setups. The first one will be watermarking, where you use, for example, a timestamp or any kind of automatically increasing column to continuously track the highest value since the last extraction. The upside of this is that only the last data is ingested. So, for example, there on the slides or on the graph, you can see that if all data until yesterday has been loaded, we will only load the new data as of today. One of the downsides is that it will not keep track of deleted records. If all of your data has been loaded until yesterday and one of your rows is being deleted in the past, and we will not, this will not be reflected into the target system. Also, you will need a watermarking column, as Pascal also discussed. This can be a challenge when using SAP data. Second will be your change data capture feature, where only the delta between two sets of data is extracted. This will very much minimize the impact on your source system and increase your efficiency. One of the downsides, and this is mostly related to ADF, we will actually need some more data flows and some more complex configurations to interpret your change feed. So now that we have discussed these three strategies, I think it might be a good idea now to see when each of these strategies can actually bring value to you. I don't think there's a one size fits all, but all of them will actually have their added value into your loading strategy. First one, full loading. It's very easy to implement. Therefore, if you have less in-house technical skills or you want to do a quick ingest, this might be the one to go. It's also good for small data sets for these initial loads, or when a complete data refresh is required. If you want to do a full load during the night or a complete refresh in the weekend, this might be a good strategy. If we look at SAP data, we typically will typically apply the strategy on these master data tables. The second one, loading with logical increments, is particularly beneficial for these large data sets, but of course they require some more partition management. So this will require some more overhead, so you will need a little bit more technical skills to handle this complexity. If you check SAP data, this might be a good approach when initially loading these large tables, for example, your financial data. If you do not want to do the full load all at once, but you really want to partition, for example, on your fiscal period. And then finally, the incremental loading, which is, I would say that the most efficient. It's perfect for large, frequently changing data sets, where minimizing your load time and resource usage is critical. Also, if your use case requires intraday refreshes of data, I think incremental loading is the way to go. However, it is very important to know that you need a usable watermark column, or the CDC mechanism should be in place. Otherwise, it will be impossible, or it will be very difficult to actually implement these incremental loading strategies. If you look at SAP data, we typically want to do this on the very large data tables. Now we've actually discussed the left part of the data lakehouse. We have our sources. We've ingested all of our data into the data lake, but now we of course want to get value out of the data. We want to get valuable insights from our SAP data that drive business decisions. In order to do this, we actually will be building a data lakehouse. And this is the fourth lesson that we will discuss today, where we see that using a data lakehouse, we can actually unlock the self-service capabilities on your data. And first, we will go over to what we understand with self-service BI, and then we will actually go over to some different components that are required to do this self-service BI. So what is self-service BI? Self-service BI empowers end users to obtain new insights fast through low-code solutions while leveraging existing and new data sources independently of an AI team. And in order to be successful in self-service, you will need an enterprise data model, consisting of multiple data sources. Before we only talked about SAP as a source, but typically in this data warehouse, in this data lakehouse, you want to combine all sorts of data. And for example, you want to complement your data with some custom master data management or some analytical dimensions that you can then later use reporting. Here you can see a visual representation of this enterprise data model. And the enterprise data model is not linked to a source system. And so it's not that we will tailor our data model specifically to SAP. No, we really want to capture the business processes and capture these business processes in a generic model. It can combine multiple systems in one data model. It's very important that we will not restrict our data model for example, containing only SAP data. No, it might be that we want to enrich our master data, or we want to combine different ERP systems. This will all be done in our enterprise data model. It should be future-proof for future migrations. If ever you want to switch between source systems, it should be easy to just keep your target data model and just complement it with new data. And finally, it should be simple and easy to digest. If we want to deliver a data model to our business users, they should be able to understand all the different objects and be able to use it to get their insights from it. Maybe it's a good idea to go over a small explanatory use case. For example, we want to make the user wants to combine multiple data sources, and we see here SAP, Excel, and Salesforce to actually make an object for the analysis. And the object that we want to create is our customer. From SAP, for example, you can extract essential customer details such as a customer code, the customer name, and even the country. But maybe you want to enrich this customer profile with some custom master data. For example, you have an Excel with a job title, with some personal emails. You actually want to complement this customer with this new information. And finally, you may also need the customer type, the customer category, and the customer contact. Now, end user to easily use this data object in your self-service BI, we first want it to be not linked to a source system. As you see that the source system is still included, we want to get rid of it. We want to have a generic data object. Finally, we also want to combine multiple systems into one data model. And here you see that we will combine multiple attributes in one dimension. And of course, we want to make it easy and simple to digest. So what we will do, instead of going from this where we have these different data blocks from different sources, we actually want to combine all of this data within our data lakehouse, as we can see. Now, another point of being able to allow for self-service BI is that we have this quick go-to-market strategy. You want to make sure that business users can very easily develop their new developments, and that collaboration is foreseen. So within Azure, we actually have this fully integrated toolset with, for example, Git and CI/CD, so that we can actually foster this fast collaboration, and so that teams can easily develop, test, and deploy new features. At last, our data lakehouse will seamless serve data to Power BI, and as such enable self-serve. Here you can actually see from the moment that our data model is ready, we can actually service Power BI, where maybe customers or end users can create own insights, and they can have bookmarks and personalize their visuals, or they can analyze in Excel. Next, we could even allow them to create own reports on top of a data set. We just give them the generic data set, and they can create reports on top of it, make their own visualizations. And finally, they can even tailor their own Power BI data set. So they can start from an existing data set and add new sources if they want.
Now I know everything about self-service and how to use it on the SAP data. A last lesson that we want to mention is that we see in the market that a lot of our customers, they are having still some systems which they have been developing for a long time. Not to say that they are already legacy when we look at the BW4 or maybe even the data warehouse cloud, which is then rebranded. They are navigating the options that they have, and when they see that Azure is a potential replacement for any of the SAP BI solutions that they have, they are asking, so how are we going to do this, and how do you suggest that we can do this? So this lesson is not a comparison between BW or DataSphere and all the other Azure options that you have. It's just really focused on what BW is and how we can migrate away from it in a manner that is that can give some confidence in the whole system of that. So when we are looking at the migration project, I I thought about it as like renovating a house. I've just finished a building project myself, so sometimes it's interesting to have these work topics relate to your private topics, and then you can see some analogies in between them. So I've asked ChatGPT to generate me a picture about this occurrence, and here you can see that it's a house near the lake which is being renovated. And when you do a renovation project, you see that there can be some things which are unexpected, things that you need to redo, that you need to put them back together. But when looking at the structure from the bare bones, it also gives you some opportunities. It gives you some opportunities to rethink the way that you have been dealing with certain challenges before. So the current models that you have in your BW or in your HANA views, they are typically very layered, very ad hoc, very all virtualized, of course. So can be an opportunity to look at these models and maybe rethink them in a way that it's not a BW way, but that it would be a Microsoft way of dealing with this data. If you are going for a full lakehouse approach, you will see that your reporting will be mainly done in Power BI. And as you will replace your tools as a PO or analysis for Office, you get a chance to rethink your governance actually that you want to do in Power BI. And furthermore, a very relevant argument in these current days is that when you want to employ AI use cases, it can be very useful that you have your data all available in a single platform. So this is an approach that we recommend to our customers. This is our vision of it. So if you have any remarks or questions, please keep them for the Q&A, and I'm happy to discuss them. What we want to suggest here is an accelerated approach, but also an iterative approach. So we follow these 5 steps. If we get the opportunity to collaborate with some of our customers who present us this challenge, this is then what we typically do. So we start with identifying the current reporting, the reporting needs, what they have. We're trying to map this so we get a nice inventory or glossary of everything that is available. And here we want to separate two things. As you know, in BW, there is this thing available called business content. We want to isolate this from the logic that has been implemented on top of that. And why? And this is where the acceleration comes in. We have our own solution. We call it Power BI out of the box. This covers a lot of the domains which are available. So we can look at sales, procurement, inventory. We can also have it applicable to a different slice if you want. So if you want to look at a procure to pay, where we just take fact tables of certain subdomains, then this is also a package that we have available. If we look at the domains that we have identified of the highest importance, let's say that we're looking at a sales deployment, then we can accelerate real quick by implementing our own version of a business content, which is then best practice formatted and set up in the Data Lakehouse content, in a star scheme, in Power BI with an enterprise model on top of that, so that we can, within a matter of days, have a data warehouse, a data lakehouse running, which you can already use to work with on your reporting needs. I am separating the custom logic because then this allows us some time to actually implement our solution, to just take it per domain, to take it per the priorities which are defined. Also important is that we don't want to do a big bang approach. We want to do it very structured. We want to do it as easy as possible, because we need to give our end users the time to adjust from their flex queries or from their Webby reports. They want to maybe they did not choose for a Power BI solution, so making this new solution land properly in terms of our end user experience, but also for our developer experience. We just want to take it easy. And if we can accelerate on the easy topics, then it is a nice win for us, which allows us to gain some time to actually refactor the logic that's being applied in BW. This is a very frequent argument, but what about my logic in BW? And there is no easy answer to that. We just need to go through the logic. We need to identify the importance of it. We need to think of it as do we still need this? Do we see another way of dealing with this? And I know these models can become very complex. We just need to have the time to actually estimate this. To estimate this logic, then we can plan to refactor this logic and actually refactoring it. And if we can then have a parallel track where we already have some things available to validate, and we can accelerate based on this. So that's our approach on moving beyond BW. Now there is one more topic which I wanted to address frequently, and this one is for the potential BW developers in here, or people who are more experienced with the whole BW structure, and that's the difference between an extractor, CDS view, or a table. And I wanted to say that an SAP extractor, it's proven its value. It's a very useful object in an SAP context. It's very clear to use. There are a lot of different data mechanisms that are working with it that are really beneficial for us and very easy actually to work with, almost plug and play. But their functionality should not be as named like a black box or something magic that is going. I've done a lot of implementations of lake houses or even warehouses where we are going directly to the tables, and this actually allowed me to gain a much better understanding of how data works in SAP and how data flows from A to B to C, and how it is actually going to set up. So the more that you work with these tables, the more that you understand the system, and the more that you can actually think about how to use it in a different way. And these tables, if we always choose for database tables, that also frees up some time for us actually, because the developer, we don't need to enhance an extractor, we don't need to make a new extractor, we don't need to write a CDS view or work with the annotations, where we can actually save some time with this. We can also streamline our process, because we're cutting away a layer that's in between the data and then our destination, in this case, data lake. So we're streamlining it and even gaining more time by having less moving parts in the whole structure. So that's a little bit my vision on how to work with extractors and CDS views. Now, a table can maybe be a little bit intimidating to work with that, to really understand how it works and what the links are. But we have made some nice reports on top of that, which allows us to actually gain a little bit more insight in how such a table is actually connected in the whole system. So you have this 100,030 tables, but the tables, they are all connected to each other, and all this data is available in the system. And here you can see with the comments that we have, with the text that we have, we can give a more meaningful name to the column header. With the text, we can see how these tables are linked to other tables. So if we need to find the description of the material type, we know that we can go into this T134 table and get some more information about that. So this is a report that we frequently use to just work with these tables, and it allows us to get a better understanding of how the tables are connected to each other without using SE80 or any other website that is out there and sometimes online or not. So that's how we see our. No, it's okay. It's okay. That we see how we can move beyond SAP BW. We have come to the end of our the 5 lessons that we have learned. Maybe you have learned something as well, and if you have still some questions that are left unanswered, then you can go ahead.
Right. There was one question from Nader Godot about how we position DataSphere, the ecosystem, the modern data platform. Maybe there's something that you can compare. Both can also complement if your question is then answered or some other question.
Yeah. So we see that the DataSphere is being actively pushed by SAP to also get this tool in your landscape, and that it's hosted in the BTP platform. Yeah, their licensing model works then with acquiring credits, and that you need to estimate how much capacity units you actually need to have this in your estate available. It can be a valid option to have this in your whole architecture, especially if you are looking at this ODP risk, and if you're thinking that this is the way forward to extract data from the source system, then what we would recommend is using a replication flow, which then already makes your DataSphere pop up into the premium tier. But using this replication flow, you can offload the data into your data lake. But you're also making your landscape a bit more complicated with adding an additional layer. You still need to work with the CDS views. You still need to work with your BW developers who need to build up the knowledge in your DataSphere developers who need to build up the knowledge in maintaining two tools in this whole architecture. You need knowledge for.
For the answers, Oscar, there are 2 more questions from the favorite Bert. So what is the impacts from the SAP node on ODP on your out-of-the-box solution, and what is the infrastructure?
So with our out-of-the-box solution, we are not using the ODP framework. We're going directly to the tables. These tables, how we address them, it depends on the parameters of the customer. Not every customer has the same need in real-time data. Some customers don't have the volume required to actually work with a delta loading mechanism. So it really depends on the volume that you have or that your customers have. So our solution, we avoid this SAP node, so we are not influenced with that. What is the infrastructure used? Yeah, it really depends on what our customers are.
Actually, it comes down to that it doesn't really matter for us how data is being pushed into data. You can work with all kinds of formats, right? So if it's SAP tables, then we will work with SAP tables, and CSS views, then we can work with that. We will always discuss with our customers how data will be included into the data. What's the best fit for them?
Yeah.
Another question from Bert. So what tool did you use for metadata on SAP tables?
The picture that I shown you was actually in Databricks. It came from the Unity catalog. So we have some scripts written there, and there we assign we fetch the metadata from the SAP tables from the system itself, and then with the correct business keys and namings, we can use this description to enhance our Unity catalog.
Yeah, so this is basically a proprietary tool, right? Something that we developed ourselves. We're just reading the SAP metadata, and we leverage information and the intelligence, the geniuses at element61 to actually give insights into what's being built in the. There's a
follow-up question.
There are a lot of follow-up questions. So lineage across systems, is that possible? So maybe that's something that I can answer. So lineage is.
No, go ahead.
All right. So lineage is basically a part of the tools that we're working with. So if you're working with Databricks, then we can use the lineage, which is available in Databricks. So that's something that we can show. We have those different layers, and we can easily track down in all kinds of ways what the lineage was downstream and also what the upstream lineages.
Yeah. Also using Unity catalog.
Indeed, using Unity catalog. Yeah.
Which
The
is
magic word.
But it's recently been announced it's also integratable into Fabric.
Lineage?
Yes,
Yeah.
the Unity catalog.
Yeah.
So we could go
as
from Power BI until the bronze layer.
Yeah, that's correct. And also there, Microsoft Fabric works with Purview. There are some connections with Unity Catalog, so they're working on lineage from end to end, so from the source up until Power BI. So that's also become available. GA.
Also, another advantage of using tables instead of CDS views or extractors is that you can really go from end to end to track whatever column that you need for, because you don't have the an object in between, which is hard to read from a certain system.
Let's come back to the other follow-up question on the previous question. So about the UDP framework, more related to layer not discussed in between database.
I'm not sure if I fully understand the question.
So maybe how I interpret this question is, so there is this DP, there's this node, SDP node on UDP. Is there impact on the layers in between? I think that's the question. So is there any impact of the SDP nodes?
With the data in Azure? No, we have multiple ways of working with the data. We have tools like Data Lake, actually, where we can estimate if records are being changed or not, and we can push this employee to Silverbolt. We can work with hash keys, actually, when we do a full load, for example, to analyze if some records are being changed or not. So no, we are not really impacted with having the data not being fetched through the ODP framework into our data lake.
Right. Sorry, it was about infrastructure used out of the box solution. The question here. So it's still.
Then I hope I answered the questions. Both of them.
So the box. Maybe it's easier that we take this offline or it's together with the Bert's. Not so quickly. Nevertheless, thanks for your questions. If there are some other questions, then
feel free to reach out. Happy to discuss these topics a bit more into detail. Thank you for attending. Hope you found this as interesting as we did, and see you later.
Bye.
Bye.